For the categorical exercises assignment, you need to start by downloading from Module 2 the categorical ordinal arthritis data. And just click and open. And you'll see the data set from class with sex, male and female, treatment, active or placebo, and outcome marked some and none, and then our N that is associated with the data that go with each of those allocations. Prior to assessing the data, since this is an ordinal outcome, we need to make sure it's ordered correctly. Most statistical software packages, if you don't tell it anything specific about the order, it will bring things in alphabetical order, and that's not what we need here. So start by highlighting the outcome, go to the columns drop-down menu, into column information. Under column properties, click on value ordering. And you can see here it's ordered marked, none, and some. Well, that's out of order. It has no improvement being ahead of some improvement. So select none and then click on move down. And you can see we're now in the correct non-alphabetical order of marked, some, or none. You'll see over here in the outcomes menu on the left, as soon as I click OK, you get an asterisk here indicating value ordering. Now remember, the N is our frequency, or the number of times each of these combinations of sex, active, marked became part of your data. So that's 16 rows of that. There's 5 for this combination, all the way down to 10 for male, placebo, and none. So what we can do here is under column information, we can go to Preselect Role and select frequency. And again, you'll see a change here next to the N in the columns menu that gives us this count that it's been pre-selected as frequency. And that way, when we do any analyses, we don't have to continually remember to tell JMP that the N is the frequency. Before we get started, we'll want to do some basic assessment of our data. So under distribution, you can see the N is already located here. I'm going to pick all 3 and just do a distribution. And now I can see that I have 84 counts for every variable. There's no missing data. And I can get the counts in proportions. So we're 70% female, 30% male, just shy of a 50-50 split on active and placebo. And then we're looking at 33% marked, 17% some, and 50% with no improvement. I would also want to do what are called univariate analyses. So the one-to-one analyses. So I'll go to Analyze, Y by X. My N is already here. I want to put my outcome as my Y and look at outcome by sex and treatment. Remember, the tests here are asking, is sex related to the outcome? And it's not asking if it's a 50-50 split of males and females. It's just asking, is there a different proportion of females by each of the outcomes compared to males? Same thing for treatment and outcome. And you can see here that we have preliminary information that treatment's related and potential information that gender could be related, but not statistically significant on its own. You'd also want to check for confounding between sex and treatment. So again, fit Y by X. The N is already located in frequency. Treatment is Y, sex is X. And we want to make sure that we don't have an imbalance of sex by treatment. And in this situation, JMP is indicating that we do not. So while we've observed that of our females, 46% are inactive, and of our males, 56% are inactive, that proportion is not statistically significantly different, so we don't have to be worried about a treatment effect being associated with gender as well. So now to fit our model, we want to go to Analyze Fit Model. And this is where we want to put the interaction in. So 1, note our N is already in frequency. We can put our outcome in Y. And now we need to get sex, treatment, and sex times treatment into our model side, into our X side. There are 2 ways to do this. I can highlight both, and under macros, ask it to do a factorial to the 2nd degree. Because we only have 2 variables here, the interaction as high as we could go is a 2 level. So you'll ask jump to do factorial to degree, to the second degree, and sex, treatment, sex times treatment. That gets our interaction in the model. There's a second way to do this, which is to add sex, to add treatment, because you cannot have an interaction without both of the primary effects also in the model. Then I click on sex here and treatment over here on the left and ask jump to cross them. And that will also give me the interaction. So to run through this again, I can select sex and treatment and do a macro factorial to the second degree. Or I can do it manually by adding sex, by adding treatment, clicking sex under the model X and clicking treatment in the columns and asking jump to cross them. It's an ordinal logistic. We've ordered our outcome correctly and I can press run. The first thing that you want to do is look at our lack of fit test here. Remember, the null hypothesis is good fit. The alternative is poor fit. We can continue on with this model because we failed to reject. And now I can look at the whole model test, which is asking me, is this model preferred over just the simple proportions of the outcome? That answer is yes. This model has more information than simply using the proportions of marked, some, or none to predict improvement. So we can look at the effect likelihood ratio tests. You have to start with the interaction. If the interaction is statistically significant, that means that your only option is to specify sex as male or female before you look at treatment difference, or specify the treatment as active before you look at the difference between males and females. With a significant interaction, that's telling you that the difference between active and placebo depends upon male or female, or the difference between males and females depends upon whether it's active or placebo treatment. This is part of the homework to interpret what this p-value means, but I've also told you in the homework about the profiler. So up here in this little red arrow, you can ask jump for the profiler, and it will give you the plain profiler first for the main effects. Under that, you can ask for the interaction profiler. And I'll make this a little bit bigger here so we can see. Now, basically, what this tells you is that for females and males in the lower left side here, there's a line for active and a line for placebo. What you're looking at is the distance between the active and the placebo within female. For a non-significant interaction, you would expect this distance to be the same as this distance for males. You're looking for parallel lines. You can go over here in active and look at the difference between female and male, or in placebo and female and male. For non-significant interactions, we expect parallel lines. For significant interactions, we would expect the lines to be not parallel, significantly not parallel, meaning that this difference is bigger or smaller than this difference statistically. So the lines may not actually cross for an interaction, but if you carried them out, they would eventually cross over. And in this case, it's not too dissimilar here. We're looking at relatively parallel lines. You could then remove the interaction if you wanted to. Click on sex by treatment up here in the effect summary and click remove. And then you could go on to interpret the results. So since we don't need the interaction profiler, we could look at the regular profiler and it will tell you females active, these are the proportions, predicted proportions of the outcomes. For males active, those are the predicted proportions. For males placebo, those are the predicted proportions. And for female placebo, those are the predicted proportions. By the way, you can simply ask the prediction profiler to output the grid table, and it will output a table of the results for you. So female active, here's our probability of each of those outcomes. That's what we predict, that 61% of females on active would have marked improvement. The odds ratios, unfortunately, are not available in JMP as discussed in class, but you can find them in the class notes, and that will help you write up your summary of the results for the analysis of this data set. Don't forget to go back and save your data now that you've ordered and pre-selected your role as frequency, so that if you need to use it again, you don't have to go back through those steps.